yeah, and then I'm gonna make the. Oh well, sorry. 1 second, I just realized something. Yeah. Okay, so now we can see it. Sorry guys. Yeah, this is the image we're gonna try to make today. So as you can see, it's an atrium space with quite a lot of light and a complex organic structure on the sides. So yeah, this is something we will be trying to make. So let's go ahead and let's start. I hope everyone has already joined us. So yeah, let's move on. First of all, let's start from constructing a point. Actually, 1 second. Let me drop a notification about the stream to our Instagram chat. Actually, we have an Instagram profile which where we put a lot of updates and all information about the upcoming tutorial sessions and other events. So I'm gonna post the link to this profile later on. So if someone is interested to see some of our previous works and tutorials, you are more than welcome to join. Also, please let us know if you would like if you would like us to make a tutorial about one of the projects presented there. We'll be really glad to do this. Um, yeah. All right. So yeah, done. Okay. Having done this, let's go ahead and let's start. So a few words about the creating this space, like before making the exoskeleton. Initially, to make sure this space looks kind of fine, we need to develop the nice overall geometry, like overall shape of this atrium. So I think the easiest way to do it will probably be making a loft from several different profiles and sections if you want, and yeah, just lofting them, making sure your geometry is a clean and untrimmed surface, and then just applying some other modifiers to the overall geometry. So let's go ahead and let's start. Yeah, I'm gonna make series of points. Let's say let's take the range. Yeah, let's say let's give the height to our space. Let's say it's going to be 300 meters. Sorry, here, and then in terms of for the numbers, you need to give like something which will make it, let's say, reasonably controlled and reasonably complex. So not too many profiles, so that it looks kind of smooth, and at the same time, not too few profiles, so it doesn't look too simplistic or too uncontrolled. I would say simplistic is probably not the best word here. So yeah, I'm gonna switch off the grid, and yeah, I'm gonna start making the profile sections. So let's say yeah, let's say I'm gonna make the radius for the polygons. I'm gonna use the polygons for the profile sections like that. I'm gonna take this like 300 number as one of my main sliders. I'm gonna multiply it by let's say 20.25, 25%, maybe even less, maybe it can be 0.2. I'm gonna connect it to the radius. Yeah, you see, this is kind of the shape of the like the size of the floors if we talk about this exoskeleton as a tower, something like that. Yeah, I'm actually quite happy with this proportion. But what I want to do now, I want to first of all I want to add the fillet radius, which will be again a factor of this. It's going to be multiplied by 0.25 again, and then I also want to make sure that our Actually, yeah, I want to make sure that my profile, my geometry will be changed throughout the like height of the building. So instead of having just one factor here, I actually want to make several factors. Actually, I want to make the same number of factors as here. So let's make the graph mapper. Let's use the graph mapper. Let's take the range. Let's connect 7 to the number. Let's pick the Bezier graph, which is like probably the simplest one and one of the most controlled also. So let's take this graph. Let's take remap numbers, bounds, construct domain, and let's say the domain is going to be from 0.09 to 0.20, something like this. I'm going to connect it here, and I'm going to use it as a factor here. You see right now the shape is actually not that different, so it's like very sorry, not different. It's just not very interesting, I would say. So I'll make something like this. Yeah, maybe something like that or like that. Yeah, like this will be fine. Then I want to make sure that the number of segments is not always 6. Sometimes I want it to be 3 or like 4 or whatever. So let's say I'm gonna make another graph. This time I might change the graph, but I'm gonna keep it as a Bezier for now. Then I'm gonna make a slider from 3 to 10, because 3 is actually the minimum number of corners for the polygon, and it's gonna be from 3 to 6, something like that. And then, yeah, you see. Then I need to change the shape of this graph, so I'm gonna make it like that. And actually, if you want to keep only yeah, I mean, it's just an experiment, so let's see how far can we get. Yeah, something like this. Okay, maybe. Yeah, then I want to make I want to add some rotation to those parts. So let's say, and also, by the way, it might be a good idea to add some eccentricity to this geometry. So instead of rotating all these profiles against the around their center, you can also move this point to another position. So for example, we can take the point cylindrical. I mean, these are like tiny details, but I think they're adding quite a bit of control and also quite a bit of like variability to our geometry. So let's say make some randomness here. Yeah, so this is gonna be rotated, and yeah, for the number, I'm gonna take the exact amount of profiles. So I'm gonna use the least length components to take the number. Yeah, let's clean it up a bit, just to make sure it's a bit more ordered. So yeah, let's bring it here. Oop, oop, and delete this. Yeah, looks fine to me. Okay, so now we're gonna add some randomness to the center of rotation. So let's construct the domain. Let's connect it to R. This is gonna be the angle. It's gonna be in degrees, and also I need the radius. The elevation should be 0 because we don't need to move it vertically, but just need to move it in one plane. So for the radius, I'm also going to take the same thing, another domain, of course. Yeah, let's take yeah, for the angle, if it's degrees, let's keep it from 0 to let's say 60. I don't know, just making it up. For the radius, let's make it again a factor of 300. So let's multiply it by, so let's use as a multiplication factor for the 300. Again, 300 is just a random number I picked. Doesn't need to be precisely this. So yeah, let's make it from 0.01 to 0.02. Well, 0.025, something like this. Yeah, then we connect this to radius, this to angle, and yeah, we use those points as centers, as planes, to rotate those parts. And for the angle of rotation here, I might actually use another set of graph mappers, and this time it's gonna be yeah, this time it's gonna be from 0 to 75, let's see. And again, I'm gonna use degrees instead of radians, so that it's a bit more clear for us humans. Yeah, let's put it here. Okay, fine. Yeah, I'm gonna connect it here, and I'm gonna select degrees. So now you see that our, I mean, maybe it's not that visible right now, but the geometry is quite gets quite twisted, which, to be honest, I like. So let's see. Okay, something like this should be fine. Yeah, and then what I will do next, I'll try to make a loft through these profiles. And as you can see, it builds the loft, but the resulting thing is an open B-wrap. It's not a surface, right? And we need a surface. So this method doesn't really work. So what we need to do first, instead of making the loft directly, first of all, we need to rebuild those curves. First of all, we need to rebuild them, right, to make sure that the control points are distributed uniformly. This will already give us quite a big difference, right? You see that this is an untrimmed surface now, yeah? Just one simple action. It's, of course, the shape is going to be slightly different, but this is going to give us quite a lot of yeah, quite a lot of benefits. Actually, the method I'm going to show you is not going to work with yeah, it's not going to work with a B-wrap. It can work only with the surface. Then I'm going to make slight changes to the rotation. Yeah, so something like this. Also for the scale, I might change it quite a bit. Something like this. Well, actually, yeah, let's try to make something nice. Okay, let's see. Maybe it should be fine. Yeah, maybe here I can change it to slightly higher number, so 0.12. Yeah, that's fine to me. And then yeah, for the rotation also we can change the degree, and we can also change the, so you can control the deformation here. Yeah, and then we can also control the seeds of both of these this random both of these random components. So you see, basically, it doesn't. I mean, it doesn't. Yeah, this is just the amplitude, but this gives us the different rotation. So you can see the shape gets rotated slightly different every time. It's not very controlled, but I mean, we can also make it controlled if we want, but this time I think it should be fine like that. then you can use the same principle as we did here to make the different rotation for the alignment centers. Okay, this looks fine to me, and now actually it's time to start building this grid. So first and probably most simple of those methods is going to be going to Lunchbox plugin, which I guess most of you might have, but actually I'm gonna add all the plugins that you need to download to the description of this session. Yeah, so let's just connect the surface and let's see how does it look. The Lunchbox is actually a really useful plugin, but for example for the hexagons, you see it creates some problems here. It doesn't doesn't make the how do you call it? Yeah, it doesn't make the continuous hexagon here, so we might need to actually change it to something. We might need to change this to join these two curves and to create a single line through them. But actually, and here if you look at this geometry, it's just a simple how do you call it, like simple grid, like diamond grid. We can also make actually hexagonal grid. It should also be fine. I think we can actually make something really nice with this approach. I think let's take it like that for now. And yeah, actually this method doesn't really work because it creates separate lines, right? Actually no, sorry, my bad. It actually does. It actually does work. We just need to take the we just need to take the seam of this loft, which is going to be the interior edge. So we'll take the curve from the side, yeah, this one, and then we need to analyze the proximity of those lines to this curve, and we need to select those lines which are too close to it, like these ones. Yeah. So we're gonna just say dispatch. Oh, sorry. Dispatch them based on the distance. So if the distance is smaller than, let's say, 0.05, yeah, let's say it's gonna be the distance. Let's connect the lines here, and then we select the surfaces which are, sorry, not surfaces but curves which are closer than this. So okay, let's move on. Let's join the curves, and yeah, as you can see now, we have, instead of having 12 separate line-like curves, we have 6 polyline curves. And let's take the end points of all these curves, sorry, and let's build lines through them. So something like this, and let's merge all these things together. That, yeah, A and B. This is our new grid, yeah. So you see that these lines are now straight lines, not like broken or bent curves. What I don't, I mean, for if we want to, yeah, actually we can continue from here onwards. Just go on. Also, one more thing that we can make with this loft, if we are not really satisfied with this result, we can also, I mean, if we want to have another direction, different direction of the hexagons, we can always make, we can always use the reverse surface direction component, and we can, yeah, we can change the, we can change the orientation of the curves. But here we get this problem because actually in this case we don't need to do this operation, we need to do something different. So I would say the best idea would be to add a stream filter and set quality to 3 as a condition, as a gate condition, right? And then actually, sorry, no, not stream filter, but stream gate. Stream gate. It's gonna be the gate, and the stream is gonna be this surface. So yeah, if it's 3, it just goes straight to here. See? Actually doesn't have any problems right now, right? Okay, so yeah, let's say we can keep those two parts. I personally prefer the first method, so I might just move the surface back to normal, to 0, so that we'll have hexagons oriented this way. And I also might add a lot more divisions here to U and V. So let's say 40, no, not 15. Say I'm gonna use 15 for U. Yeah. Here, as follows, it should be for V if we want to keep a more or less same proportion. Here I'm gonna use the same for V and U respectively. Also, it's very important here to use an even number, yeah, for V. So I might instead connect another slider multiplied by 2, and 2 will go as a panel because we don't need to change this number to anything else. Yeah, Shift Control to drag and reconnect those numbers. Yeah, there we go. Alright, actually this looks fine to me. We might also use a very similar approach for the diagrid structure. Yeah, so instead of using the hexagonal structure, we can use the diagrid structure, which is also fine. But actually this time I want to use the hexagonal structure. So how can we make our grid a bit less, I mean, it's not boring, I'm not saying this, but it's really uniform right now. Basically it's very regular. So what we can make in order to change this, we can, yeah, probably I'm gonna, I'm gonna trim 3 here, because you see we connect two very similar data structures together, but as a result we get a data tree with its paths having different lengths, which is quite bad every time. So you should try to make your data structure as clean and correct as possible. So right now it's basically merged into one data stream, right? Sorry, into one tree branch. Okay, so in one list if you want. Okay, so now let's add some how do you call it? Yeah, let's add some irregularity to this grid. So what we can do, we can take again we go to lunchbox. No, sorry, not lunchbox. I think it's Heteroptera. We can take the network. Do we actually need to make the network? Sorry, 1 second. From lines, this one. We can take this one. Here we find the points and we find the lines. Here we find the point topology. Also we find the connection point topology, which is actually good. So yeah, let's take those points and let's also take our initial surface. Let's go for populate geometry and let's add, I don't know, 9 points maybe, something like this. For the seed, we're going to use some number in between 0 and 100, so maybe something like this. Yeah, those are going to be the points which are going to be which are going to distort our grid. And then I'm going to go to Pufferfish, and I'm going to go to what is it? It's called pinch and spread. It's in points. Yeah, it's in points. Pinch and spread. So I'm going to use the yeah, I'm gonna use those points as locations. Then I'm gonna use those points as points as list, and we need to have the strengths and radiuses. So for radiuses, again, let's take a factor of 300. Let's multiply 300 by something. I don't know. Let's say 0.05 maybe. This is basically the distance at which at which the points are going to affect the grid. And then for the strength, I'm going to use something. Again, you can make something random, just for the sake of time and showing you the showing you the principle. I'm going to construct domain, and as you can see, the strengths they don't go from 0 to 1; they go from -1 to 1, where we will need spread. There are basically two behaviors: pinch when it drags points towards itself, and spread when it moves points away from itself, right? So let's make it from 0.5 to I wanted to spread it. I wanted to spread the points, so we need to go from we need to make it negative actually. So let's make it that. And then I'm gonna add a negative component after the random. Yeah, so you see that the points are gonna be moved slightly. Yeah, see. And now we basically just need to, if we want to assemble them in the same order they were before, like to make lines from one point to another, just need to go for connection point topology. You connect the points here and connect the point. Sorry, a second. Is it correct actually? Yeah, it is. And then we make lines. We create a line. So we go for actually we can, instead of using lines, we can just go for polyline to save one or two to use one or two fewer components, let's say. Yeah, and as you can see now, we can increase the strength of see, basically the points get moved away from this part. Yeah, I mean it doesn't look very strong, so we might increase the radius. We have to distort the grid a bit more. Also, I really want to make it more. I want to make it more bending. See, something like this should be fine. Yes, maybe something like that should be fine. No? Yeah, and then also I want to increase the rotation of those profiles. 180. Make it more like this. Okay, looks fine to me. I mean, we can play with this anytime. So yeah, I'm just gonna keep it like that for the moment. Maybe also how to rebuild the surface. Yeah, it helps us to make the grid a bit more controlled as well. But I don't think it's necessary right now. Yeah, so we have all these polylines, and now actually we can just just play with those distances. Yeah. Okay. So fine. Fine. Exponents. Weights. Fine. Anchors. We can also increase the weights. Actually, if we want, we can make it a bit more significant. Yeah. See, if we increase it to 1, starts moving the points quite significantly. Yeah. But yeah, as said before, I don't know if it's necessary or not. Anyway, it's fine like this for me. So let's basically it's time to make the exoskeleton. So right now I'm gonna use Shift Plots. It's a component from Tree Sloth plugin, which is another really useful one, which I really suggest you to use. It basically does something very similar to trim tree, but it works a bit better. We might talk about it in more detail in one of our next streams. Actually, by the way, let us know if you would like us to make a stream. Well, we call it a stream for nerds, but like nerds in a positive connotation, not a negative one. It's gonna be a stream where we were gonna be like a live session where we're gonna be talking about some tricks that you might not know about Grasshopper, how to speed up your work, how to speed up some processes which are not maybe not always very spectacular, but at the same time play a very big role in speeding up your workflow, in data management, in yeah, all these type of tricks. Let us know if you would like to have a session about this, and then we will be talking in more detail, like comparing different components from different plugins that are used to control the data and manipulate trees. So yeah, let's now move on. And yeah, basically now what I want to do, I want to give some mass to this structure. I want to make it more like that. So I want to make it more more as an exoskeleton, not just a network of lines. I want to make it a network of like mesh. So for that, I'm going to use we can always use multi-pipe, of course, but actually that's not what I want to do. I want to make something much not much. Let's say multi-pipe is an amazing component, don't get me wrong, it's really useful, but it has one problem, that sometimes when the radius is too small, or if it's very yeah, if the angle is too sharp, the multipipe can go crazy, and that's why I suggest, before converting our geometry into a sub D, I suggest us to use something slightly different to prepare for this. So yeah, let's take the points again, but this and the lines as well. Yeah, and this time I want to use the plugin that is called Mesh Fattener. It's a pretty old one. Sorry, is it? Yeah, this one. It's called fatten. Yeah, this component. So what it requires a skeleton, which must be a network of lines, and as you can see, it immediately creates this structure, which looks quite similar to a multi-pipe, but I mean, it has this very similar. It has the same topology, but it works even with really sharp and really angular structures. Let's say when the angle between two lines is very sharp, or when the distance between 2 points is very small, it will still work fine. That's why sometimes I prefer to use this component instead of the multi-pipe one. But again, multi-pipe is an amazing component, so and I'm pretty sure it's going to be improved in the following versions of Rhino. So yeah, let's take this component and let's also it uses the same principles with the spheres, but the problem, like the benefit of the multi-pipes compared to this component, is that for multi-pipes you just need to set the point sizes and give a specific size for every specific point. But here you need to actually create spheres, like NURB spheres. And the main problem with it is actually just the preview, just previewing the spheres. So I recommend you to group them, call it something like heavy, don't click, or like something like 3, I don't know, something just to make sure that it should not be touched, it should not be previewed, because your computer can just not crash, but it will take a lot of time to preview them, so it's better to keep them hidden. Then we connect these points here, right? So nothing happens, you see it works really fast, all is good. Yeah, you see, basically it's the same because it has the default settings. And then we can start controlling the radius of different nodes to make sure that our geometry will be will have different geometry. So let's go for the graph mapper again. Attractor geometries, just not to create another attractor, but again, you can also create an attractor in 3D. I'm going to use these points as geometry. Those points I'm going to use as points. yeah, then we're going to use the least normalizer. This one. Yeah, we're going to connect it to the graph mapper. We're going to use the Bezier graph again. And then we're going to use the remap numbers, bounds, construct the name. Yeah, let's say the radius are going to be from 2.4 to something like 9, maybe even more, I don't know. Also, I mean, of course, it should be better, it will be better if we make these numbers a factor of 300, because it's like a number we are... yeah, okay. We need to make... Yeah, you see, we can make it really extreme. Yeah, this difference, which actually I think looks pretty cool already, but we can also make it even better. Yeah. Okay, so right, let's say, yeah, also it's 0. We need to give it some mass at least. Yeah, and then we can also give it the thickness, like the thickness is 1 right now, so let's make it a bit, maybe less, even less. We can make it something. Actually, yeah, let's bring in the 300, this number. Yeah, something like this. And I'm gonna multiply it by yeah, I'm gonna multiply it by, let's say, 0.01 to give me 3 meters, maybe even less, 0.005, let's say something like this, and to 0.03, something like this, which will give me approximately what we have right now. And for the thickness of the skeleton, I'm going to use an even smaller value like this. Yeah. So this is going to be the thickness. This is going to go here. This is going to go here. Yeah, and then this number is going to go here. Yeah. Okay, so this is our fattened exoskeleton, right? And then yeah, we can just directly create a sub-D from mesh, because this is a mesh. It's one quite uniform mesh. Yeah, so this is it. One more thing is actually that might be nice to have some sticks going to the going below. So what can be nice is actually making your it should be done at the earlier stage. Let's say here. Oh, sorry, here. Yeah, for the linear structure, or actually maybe here. Sorry, my bad. It should be here. After this stage, we can always add some lines SDL to the top and to the bottom of our structure. So let's actually take our points. We can just use discontinuity. Yeah, this. We are gonna say shift dots. This. Yeah. We're gonna deconstruct the points. We're gonna yeah, we're gonna take the we're gonna sort list based on the z coordinate, and we're gonna select the highest and the lowest points from our entire list. Actually, we also might just connect, instead of connecting the points, we can just connect the values, like the z value, and we can say if it's yeah, then we can go for list item. We select the first, which is like the lowest, and the last, which is the highest, and then we can go for equality within tolerance. Yeah, we can connect these two. We can merge these two values together. Sorry, actually, we should not connect them together. We should just, yeah, let's take them separately. It's fine. We just connect those numbers here, and the tolerance will be something like 0.1 meter. Then we say cool pattern. points. Yeah, see? We pick the highest points and we do the same but for the lowest points. So we do a similar thing. Yes. Yeah, so now we select the lowest points as well. Then we just say remove duplicate points. 1, 2. Yeah, we make line SDL. So here we bring them up. We move those. We point them up, following z vector. So let's say it's going to be something again 300 multiplied by, I don't know, something like something like 0.12. I don't know, just making up these numbers. Oh, this is actually not too much. Yeah, something like that should work. Yeah, and here we do the same, but here instead of pointing them up, we should point them down. So we should go for -x here. And then after all these things, we just need to merge these lines together. Again, we need to shift paths, I guess. Here. We can actually trim tree, doesn't matter. We just need to remove one figure from each path. This, yeah. Here. Yeah. So yeah, as you can see, now our geometry is a bit more. It's like standing on the ground and also points up. But in order for this to work, we need to also go to fattener and select the end type. In our case, I want to select 0, which will be open. Yeah, so you see they are going to be open here, and we will be able to kind of connect them to the ground, attach them to the ground, whatever. Yeah. All right, perfect. So yeah, now maybe it's also better to decrease this number quite a bit. Maybe 4. Okay, this looks fine to me. Yeah, and then a few more things about yeah. Let's give it some color. Let's say we're gonna make a custom preview. Like this. Watch. Make something like this. Yeah, and if we go to rendered mode, like this, you see we are basically getting this geometry, and then I mean, yeah, it doesn't look exactly as we as in the image, because this was also taking quite a lot of additional let's say post-production. But if you pick a right angle, you can actually achieve a pretty spectacular result from this space. Also, even from the side, I think it can look quite nicely. But also, yeah, what we can also do, we can also control this grid in terms of where is it? I think it's here. Yeah, length divisions. So let's create a slider from 0 to, let's say, 3, and let's connect it here. You see right now it looks quite blobby, right? But then if we want to give it some more, you see we can make this structure look more, so to speak, more straight, more angled, yeah, if we change the divisions. By the way, we made, like, I think a couple of years ago, we made a tutorial session about working with sub-Ds and meshes and making some transitions between these two types of geometry. Let us know if you'd like us to make another session about a similar topic to explain how does the amount of subdivisions affect the aesthetics and behavior of the mesh and of the sub-D as follows, and we will make it. Yeah, so now a few more things before we finish our session. First of all, I'm gonna change this parameter a bit. to make it not so thick. Yeah, I think I start liking it actually. Yeah, then we will just we can also increase these numbers, something like that. Yeah, actually, I start liking it. I think it looks not bad actually already. Yeah, yeah, there we go. So yeah, you see, basically we get some more. Like as soon as we increase the detailing of our grid, it becomes more clear where it gets open, and all these like thickness differences also become more obvious. So I think this yeah, now I think it starts looking pretty cool. Okay, also I think yeah, we will be also making. Yeah, by the way, drop us a comment if you would like us to continue this geometry and show how to set up the angle, the camera, everything in Grasshopper, of course, how to set up the materials, how to make some conceptual renders in Grasshopper. We will be more than glad to make another session about this. And yeah, I mean, just wanted to show you how fast is and how resilient is this workflow. So as you can see, we can change the geometry in almost any way we want, and it goes really fast. Yeah, I mean, we can also make something like this. Yeah, actually, yeah, this is actually not bad. Yeah, this is like the shape. Then I'm also gonna play a bit with the thicknesses. Also, we can increase the strength of the with distortion. Yeah, for the thickness of the for the thickness of the um, thickness of the exoskeleton, I might also change this. But yeah, I think the most difference will be visible if we make it more extreme here, like this. Yeah, something like that. Yeah, and then of course, for the rotation, we might just twist it a bit more. Also, we might just go for the crazy if you want to. Yeah, actually, it's not doesn't look bad to me. That's maybe a bit too much. Um, can also make something. Actually, this looks kind of cool to me. So I might just keep it like this. You know, I think this type of yeah. And what is good about this workflow is that you can change, especially at the conceptual stages of your project. You can actually, this already looks quite similar to the render I was showing to you in the beginning. So I think this is actually yeah, this looks pretty good to me. But yeah, basically it's really it gives you a lot of freedom and a lot of speed at the initial stages of form finding and conceptual design. And once you're done with the initial shape and the initial aesthetics, you can also increase the complexity of this grid. You can add second layer, for example, to this. You can add another layer to this geometry to increase the complexity even more. Uh, by the way, um, by the way, yeah, you can also make a grid which will go in a different direction as a spiral. So there are many possibilities, but the principal workflow is this. Yeah, so it's quite straightforward and quite simple. I'm gonna actually move my screen a little bit along the script, so you can so those of you who are following the script and didn't following the stream and didn't manage to um, follow everything, you might be also able to catch up. So Yeah, let's bring some order to this mess. Yeah, I'm gonna be freezing my camera in the different parts of the script, and you will be able to follow, like you can pause the video and just follow the script and add any part that you need. Yeah, so let's go here. Yeah, again, as mentioned before, feel free to send us your feedback. If you would like to see one of our projects explained, drop us a comment or direct message on Instagram. We'll be more than happy to help. And yeah, I think we're going to be making an announcement about the topic of the next session sometime during the next week. Maybe Wednesday or Thursday we will make an announcement, and then the session will be organized next weekend. Yeah. Okay. So yeah, this is this part. That part. This. Yeah, that's it. Yeah, last thing as maybe maybe as a bonus. I don't know if it's going to be very relevant, but what you can also do if you want to increase the complexity of your like geometry even more, it's necessary, of course. You can go for Weaverbird, and you can also make this geometry more subdivided. So instead of yeah, in this case it will actually it's gonna look same, but in this case you will have more polygons, and you will be able to make some crazy things like this one, for example. So there you see, and then you can add some thickness to your geometry. It's already quite yeah, quite big. Let's make it 10 times less. Yeah, something like that should be fine. And then yeah, then we can convert this to a sub-D mesh. Sorry, to a sub-D from mesh. Maybe it's a bit too much. Let's see if my laptop can handle this. Yeah, it can. You see? So you can also make something like that. Yeah. I'm not sure if this is like, yeah, I'm not sure. Again, more complex does not necessarily mean better, for sure. Sometimes actually less is more. Sorry for this kind of banal phrase, but it is what it is. Yeah, so I guess we can, yeah, I guess we can conclude our session on this thing, on this geometry. We can disable that. I'm gonna keep it here as a group, just in case. Yeah, so thanks to everybody who was attending this session. I hope it was useful, and yeah, let's stay in touch. Goodbye.